Hello. In this video I'm going to make a quick demonstration on how to connect Minla receiver board to NASA flight controller. What I have here on the table is the drone quadcopter. It's actually the pretty standard quadcopter. You see, it's nothing special in here. It's just 4 motors, 4 electronic speed controllers right here, NASA MV2, and that's it. And here I have the Minla receiver board. It comes in this 3D printed plastic box. We have a camera, and we have USB port for USB modem, and the pin header for connecting to NASA and various other devices. So first I'm going to mount it on the drone. I can use the VHB tape, like for instance NASA is connected on this double-sided sticky tape, but instead I'm going to use this rubber band, so it's just easy to fix it. So I've got my Minla board fixed on the drone frame, and in order to connect it I will use this connection manual, connection guide. And first I want to connect is the NASA channel A, E, T, R and U. And for this I got to use 13, 14, 15, 16 and 17 pins. And the pins are described right here. So I gotta be using this, and this pin. And there is another page how to connect it to NASA. It's basically I'm going to connect the signal wire to this and this pin. So it's very easy. So what I'm going to use is this cable on both sides with connector on the both sides. And I already connected it to the NASA flight controller, and what I'm going to do is to connect it to the Minla receiver board. It's very easy, it's right here. The next step is to connect the power wires. The power goes from NASA as well, so I've got these 2 red wires. And on the manual I have the description. I gotta connect these red wires to this and this pin, number 3 and number 4. So what I'm going to do is to do just that. I will connect it to NASA like this. Okay, and then I'm going to connect the ground wires. And again, using this manual, I'm going to connect ground wires to pin number 1 and 2 on this picture. And I have the black wires here. It's just very easy, just really easy. Okay. And what I have here is this. And the next step, to connect everything to Minla receiver board. So I'm getting these red wires and connect to the most right pins and the ground. Like this. And we've got two wires unconnected. The one wire is for GPS, so we connect it to the fourth pin on the top row, and on the picture we have this pin number 4, this pin. It's GPS RX data input from NASA GPS, and we connect the opposite side of this wire to NASA, and for this we use this little adapter. What it basically does is this wire, this red wire, is connected to this pin, the second from the right, and by this we can take the GPS data from the NASA GPS module, and we just basically connect NASA GPS model. And we still have one wire left, this green one. I'm using it for measuring the voltage of lithium polymer battery. I'm using 3S battery, so, and that's why I'm connecting into this pin. I believe it should be pin 12, and description is LiPo 3S voltage measurement. And the last thing we forgot to connect is the USB modem in the USB port, and I'm using the Velcro tape to fix it firmly, like this, and that's it. So after we connected everything, the next step would be to open and set up the control panel, and it's actually very easy as well. This Minla board comes with this unique ID number, and I'm going to control my drone from the mobile phone. This is the Android mobile phone. Okay, so we are now out in the field, ready to make a demonstration flight. But before I do that, I just want to make a brief look at the control panel itself to see how it can be set up and what features does it have. So before we begin, it's a good idea to turn on the non-disturb mode, just in case somebody will give me a call. You know, I will not be interrupted while controlling the copter in the flight. Also, I have, you may notice here, H means that I have 3G connection. I don't have a really good 4G signal here, so the network can be interrupted, and I don't want to lose the signal. So, but 3G should work pretty good as well. So let's begin by opening the browser. I'm using the native Android browser. You can also use Google Chrome, but I just found it more useful and more easy, and it actually gives the more speed in terms of JavaScript processing. So I'm opening the browser in the landscape, and then I go to bookmarks, and here I have minla.ru and etc. This HTML file, which is actually the URI to control panel. It's version 0.07 right now, and you may notice the question mark and then ID and then some weird set of numbers, and this set of numbers is actually the unique ID of my specific Minla receiver that I have on my drone. So if I open this control panel and then I establish the link between my phone and the Minla receiver, no one else can connect to my specific Minla receiver. So this unique ID is actually the quite good safety feature. So I just click it, then I have the web page loaded, and it's like this, and just reload it in case. And why I use this native Android browser is that because it allows me to put it in the full screen like this, which is very good. So let's look at the features of this control panel. First, let's go through the buttons. Into the left top corner we have the on and off button. What it basically does is that when I press it, it lights yellow, means that my phone is now connected to server and waiting for Minla board to connect the server and my phone. So when it turns green, it means the connection is established and we are ready to fly. So for now, let's just switch it off. Then we have on the bottom we have the menu button. Here we can change the JPEG resolution, the video resolution. And then we have video quality, and then we can zoom it. This control panel is designed to work with phones. It can be iPhone, it can be Android phone, it can be iPad, it can be Android tablet. So, and it behaves actually quite differently when it's run on the phone with the small screen and when it run on the tablet with the bigger screen. On the tablet you can actually select the position of the video, because the sticks will be much lower than the video canvas here, and then you can just click, you can drag it with your finger in the area where you want it to be. So we can actually zoom it full screen like this, so the video will be full screen, and then it can be fit height, so it will adjust the screen height. But I just used to fly on the 1X. And then we have a button like CHCAL, it's channel calibration. You know, when you set up NASA, there is an option in the NASA setup software where you can calibrate the channel, and then you basically first click the calibration in the NASA software application, and then you press the CH calibration here, and then it will calibrate it automatically. Also, we have here the magnetometer calibration. It can be used in field, but I have the specific button on the Minla receiver, so I don't need actually the control panel to calibrate the magnetometer, to calibrate the compass. So the next we have GPS, CTTI, and fail-safe button. So it's easy. It switch into these modes. By default it's GPS mode, but you can also change it to ATTI and run it in the fail-safe. And then you can switch on and off video. That's for instance when you can use you can connect the second receiver, like a regular RC 2.4 gigahertz receiver, and maybe sometimes you don't need a video, you just want to see the position of your drone on the map and get the telemetry, and yeah, you can just switch it off in some cases. And then the next button here you have the startle is the slow mode, slow controls, and this actually, let's talk about it a little bit more. Here on the bottom left corner you have the sticks. You have the left stick and the right stick, and the left stick is basically when you move your finger in the top and the bottom, it's a pitch control, and when you move to the left and to the right, it's a roll control. And you can see these numbers on the right and on the bottom of this stick. It's actually the two numbers. It's a red one and a green one. And when you move your finger, let's look at the numbers on the bottom one, and green right now it's 900. And the full scale of the pitch and roll is actually 1000, from 0 to 1000, but I intentionally limited to 100 in the bottom and 900 in the top, so it's pretty close to actually the full range of NASA sticks, how to say, movement. So for instance, when I used my drone in the full stick, when I pull it to 1000 and the pitch, it can speed up to 60-70 kilometers per hour, but it's very rarely I need this, so it's just when it's 900, I guess it will be about 60 kilometers per hour, which is quite good, I think. And when you press the slow controls, it only can go to 750. You see that it limits the range, and it's actually very useful when you don't want to get a full speed, when you can easily make mistake, like move your finger about centimeter in each direction, and your drone will speed up on the next 30 kilometers per hour. When you don't want this, you can turn on the slow controls and be safe in the flight. And on the right side we have the map. This green button, you can hide it and pop it up again. When the drone is connected to my phone, this red spot on the map will be updated automatically, and it will show the current position, current location of the drone. And then we can do it full screen. We still have the telemetry in the center and the bottom visible, but we also have we can change the layers. You can change the satellite, hybrid, and
like showed in a different ways. And there is another button like H, which means home. So when I press this, I fix the home point, and later it will be used to calculate the distance from the current drone location to the home point, and the home point is always fixed until you press the H button next time. And one button left is the button, the blue button into the right top corner, which is actually the run and stop motors. So press it, motors are run, and you press it again and motors will get stopped. And that's it from the buttons. And in the center, in the bottom, we have the telemetry. Let's start from the satellite sign. It's red and it's 0. It means that right now it's 0 satellites connected to another GPS module. It means that another GPS module found the 0 satellites, and the red one means that there is no GPS fix. It could be yellow when it's 2D fix, and the green where it's 3D fix, and the number of satellites should be about 10 in a normal, or about that. Then in the bottom we have a battery sign. It's also the useful feature. Here you get the voltage of the battery, so you can approximately calculate how much time you have left for the flight. And the next, this one vertical sign is the altitude above the ground. Next is right here is the speed, the current speed in meters per second, and the last one is the distance from the home point, home spot, which you fixed on the map, and the current drone position. And I guess that's it. So let's try it in a real flight. So we are out in the field. So this is the place where I will try to launch the drone. I will connect the battery, and I will connect this green wire for measuring the voltage on the battery to the third red pin, and we will fly then. So here we go. I got it connected, and I will switch to control panel. Now it's about -5 or so, so I don't know how long I will survive outside, but let's see. Yeah, so I have my drone connected, and here you can notice on the left top corner the frame per second and the size of the frame. Now it's 7 frames per second, but that's because a lot of contrast elements on the picture. Usually it should be about about 6,000 bytes, and the frame per second also depends on the network quality. So in the various areas I have from 7 to 11 or 12 frames per second. But here we have drone connected. We have a video stream. Also I'll check GoPro if it's filming. Yes, it is. Okay, so let's try and test it in the flight. Also you can notice on the map we have the spot, so I fix it here as a home spot, and I will run the motors and take off. Here we go. I will also enable the slow mode because I don't want to fly really fast. Just a little bit circling around. So all communication works here via the internet right now. So I don't have any other receivers connected to the drone. So just flying around, and let's actually try to test what's going to happen when the network is disconnected. So what I'll try to do is to just switch it off. Push the button. Yeah, well, it doesn't work really good, and I can't remove the SIM card from here. So yeah, let's try it. I will just try to do like this, and the drone right now flies, and after it identifies that the signal was lost, in 2 seconds it will stop and wait for reconnection. And now I will turn it on again and see if it gets reconnected. So it takes some time because modem is switched off and switched on again, and it takes some time for it to find the network and to actually establish the connection. It's about 15 seconds or so. But still the drone is hovering over the same spot during that time. Okay, so here we go, we got reconnection, and you see that also the a little bit increased in frame per second, so we can continue flying. When the voltage drops below the certain level, the battery sign becomes yellow, and when it's critical it becomes red, so indicating that the power is getting to the limit and it's time to land. But I will not do that, will not push it to the limit because of the freezing temperature here in the Moscow region. So I will just land the drone and go somewhere in the warm place. Oh. So when I landed, I just press this blue button again, and it stopped motors. So now I can disconnect the battery, turn off the network connection, and just disconnect the battery, and that's it.